falta el aire y el corazón tucum, tucum, tucum.
Okay, so welcome back, good morning. So we're going to talk about topic 10, applications of Newton's law. So first of all, I'm going to give you an introduction of Newton's laws. So the first one is the law of inertia, that states that every object persists in its state of rest or uniform motion in a straight line unless it is compelled to change that state by forces impressed on it. Now, the second law is the fundamental principle of dynamics, meaning force is equal to the change in momentum per change in time. For a constant mass, force mass times acceleration. Force is going to be equal to mass times acceleration. And the third law is very simple, action and reaction, meaning that for every action there is an equal opposite reacting. Well, yes, a reaction. So we're reacting. So now I'm going to explain you the applications in physics of those laws of motion that were stated by Newton. So we're gonna solve several exercises to involve the second law of Newton. Several exercises meaning one, so you only need one to understand it. So what is the tension, meaning T? Okay, I'm just gonna show it to you. I have it written right here. What is the tension, meaning T, in the rope of a 20 kilogram object block if it is accelerated upwards at 8 meters per second squared? What is the tension if T is accelerated downwards? So first of all, we're gonna do the graphic, okay? So we have the cord, meaning the tension. So this is a x and y axis, like coordinate plane. So of course, if it's going to be accelerated upwards, we have a positive value, and if it's downwards, we have a negative value. There's some values that are always going to be negative, like gravity, because it's always going downwards, so it's going to be negative. And since we don't have any values in x, we're just going to act with the resultant force in y. So first of all, forces in y is going to be equal to mass times acceleration. So the formula is tension minus, because gravity is always going to be negative, mass times gravity, that's how we get the weight, equal 20 times plus 8. Plus 8 because it's going to be upwards. So what we're doing here is a simple multiplication. Simple multiplication here too. So we have a negative here and a positive here. We have to clear for T. So this one goes to the other side adding. So this is going to be the final value. Tension is going to be equal to 298 newtons. Newtons because 8 is going to be meters per second squared, and this is going to be kilograms. So kilograms times meters per second squared, it's equal to newtons. Now, if we want to do it the other way around, we just need to change the sign in the acceleration, that is 8. Same procedure, multiplication. We have the same values but a different sign, so we only pass it here, this one adding, so the result is going to be 36 newtons. It's a pretty simple topic. Hope you understood how to applicate the Newton law. This time specified in the second one, that's force equals mass times acceleration. So thank you.